Okay, welcome to video 12-4A. This is going to be the first in a series of 3 videos for this lesson 12-4. Pretty quick lesson here with Explain 1. We're going to be finding what's known as a geometric mean of pairs of numbers. So look at our definition above here. We're going to consider a proportion a to x equals x to b, where 2 of the numbers in the proportion are the same. The number x is what we call the geometric mean of the 2 numbers a and b. So you're going to be setting up a proportion, and between the 2 numbers, so looking at example 1 part A here, you're given 4 and 25 are the 2 numbers. So you're going to set up a proportion that 4 to your unknown number, the geometric mean, equals the geometric mean x over 25. It's always going to be set up in that exact same way. And so when I cross multiply, which I can do and skip kind of some of those middle confusing steps a little bit, in my opinion anyway, I don't think they're necessary. So we're going to cross multiply, and we're going to get 4 times 25 is 100, and x times x is x squared. We're right here. So when we undo and find a geometric mean, we have to take the square root to find from x squared down to x, and notice that the definition does also say that it's the positive number x that creates that proportion to be true. So while we would get both a positive and a negative 10 here, we only want to use positive 10 as our answer. In part B, we're going to fill in. We're going to write the proportion. First, we're finding the geometric mean of 9 and 20. So we're going to say 9 to x is equal to x to 20 in our proportion. And then we cross multiply, and we get 180 equals x squared. Now, this might be a little tricky as far as simplifying the square root of 180. So remember our strategy of finding that biggest perfect square value that divides in. I'm just going to make a quick little factor chart here for 180. And see if we can get to a perfect square. 1 and 180, 2 and 90, 3 times 60 is 180. So as I look down my list, remember we want to go from the largest factor down. None of these are perfect squares yet. Let's see if we keep going what we get. 4 divides in with 45 as the other pair of that factor. That's not a perfect square. Let's see what the next one holds. 5 and 36. Okay, good. Winner, winner right here. 36 is our perfect square factor. So if we go back to over on the side here, breaking down the square root of 180, we have the square root of 36 times the square root of 5. Remember to put the perfect square factor under the radical in the front, so that when I simplify, we just get 6 radical 5 for our answer. Okay, you've got 2 your turn problems with these geometric means at the bottom of the page here. So take a pause in the video and make sure that you check the answers online. We'll see you in the next video.